Okay, welcome to day 9 of Advent of Code. Let me drop a link in the chat. Good morning, everybody. It's weekend, so it might be a bit of a longer one today, but yeah, let's just see what they have in store for us. Yesterday was fun. I made a small clip of that. If you haven't seen it, go watch it. I was really pleased to get that final star. So yeah. Mirage maintenance, day 9. You ride a camel through the sandstorm and stop where the ghost maps told you to stop. The sandstorm subsequently subsides, somehow seeing you standing at an oasis. Those are a lot of S's in a row. Sandstorm, S. Okay. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be another giant floating island. This one made of metal. That must be where the parts to fix the sand machines comes from. There's even a hang glider partially buried in the sand there. Once the sun rises and heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of desert island. It must have been a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time, your puzzle input. Each line in the report contains the history of a single value. For example, and then we have a sequence of numbers. Sorry for that. Let me take a sip of my coffee. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the differences at each step of your history. If that sequence is not all zeros, repeat the process. Using the sequence you just generated as the input sequence. Once all of the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. Okay. In the above data set, the first history is 0, 3, 6, 9. Okay, so that increases by 3. Because the value increased by each step, the first sequence of difference that you generate will be 3, 3, 3, 3. Notice that this sequence has one fewer value than the input sequence because at each step it considers two numbers from the input. Okay. Since these values aren't all 0, repeat the process. This value differs by 0 at each step, so the next sequence is 0, 0, 0. Okay. That means you have enough information to extrapolate the history. Visually, the sequence can be arranged like this. Okay. To extrapolate, start by adding a new 0 to the end of your list of zeros, because the 0 represents differences between the two values above them. So this means there is now a placeholder in every sequence above it, A and B, okay? You can then start filling in the placeholders from the bottom up. A needs to be the result of increasing 3. The value of its left by 0. The value below it means A must be 3. Finally, you can fill in B, which needs to be the result of increasing 15. Okay. I wonder why this step is needed, but okay. Because if you can figure out the formula for this increase, you don't need all of this, I think, but that's fine. So the next value of the first history is 18. Finding all 0 differences for the second history requires an additional sequence. Okay, let's see. Then, following the same process as before, work out the next value in each sequence from the bottom up. Okay. So is this a different set of values, or am I missing something here? Let's see. Oh yeah, okay. So this is a new set of values. Okay. So this one becomes +3. So this is a running increase of 1. Right? So it starts at +2 and then adds 1 over time. So I think all of this is nice but not needed if you can figure out what it actually does. Okay, but let's continue down this path before I try to be too clever. Then, following the same process as before, work out the next value each subsequence and each sequence from the bottom up. So the next value of the second history is 28. So yes, +6, +7. So this is everything. You can do this without doing the others, but you have to be able to figure out what the steps actually are. The third history requires even more sequences, but its next value can be found in the same way. So this is +3, +3, then +5. So it increases by 2, then it increases by 4, then it increases by 6. Okay, so the increase is +2 here. Right. So it's 2 more than previous, so this is 4 more, this is 6 more, this is 8 more. Oh yeah, you can see that here. So the next value of the third history is like that. Okay, if you find the next value for each history in this sample and add them together, you'll get 114. Okay. So now the interesting thing is, because this is actually, I never seen this before, but this is actually a nice way to find the repeating pattern of these numbers. Because yeah, I know you've always seen like these questions, right? Predict the next number, and it's always hard to do. But if you take this approach, it becomes fairly obvious. So it's actually teaching you something, which is quite nice. I'm just thinking if I want to do it this way, actually this is what you do underneath the logic, so that should be fine. Because this is the step increase and this is the rolling count. So if you have a first row, if the third row is zeros, the second row is just your basic increase. And if you have 2 layers, this is your basic increase that increases by the third row. So you have a start number that follows a pattern. So for here, so I think you can do this, but in this case the pattern only starts after the first occurrence. So is it always like that? Maybe I'll just have to implement this and just see if I can if I can do that. So yeah, this is interesting. These are a lot of numbers. We have negative ones and positive ones. It might be fun to just actually implement this. So let's try this. So let's first format the input in the test input the same way as the real input is done, because these are 3 lines, but the real input is just 1 line separated by space. So that's the first history, and then we need to have the second history as well. So let's take that one as well. And let's the third history here. This is the third history. This was the second history. This one was the first one. Oh, let's see. Ah no, this just has those values, so I just need to separate those. this. So these are our test inputs. Right, yes. Let's take our code, clone day 0, make a new day out of it, and this one becomes day 9. Okay. If test input becomes this. Oh man, I keep having to cough. Okay, so let's see. Basically, you can do input. Let's see, outside it, input 2 lines. Select. No, not to look at. Let me increase the zoom level here and make this fill the screen, something like this. We do 2 now, 2 lines, and then we do select X and whites. Split by ASCII white space as in 32, we can do in 64s, why not? So var histories equals this, and this is a list of long. This is fine. Let's just do it like this and make it available to both data sets. So here we have it like this, and then we have it parsed. Right. So now we can do for each of our, actually, you need to have a, how do we call it? Because if you go from here, you will have a base value and an increaser. So I think we will have to have a, do we generate these? Why not? Let's just do it. INumerable long generate diffs. INumerable long values. Like this. Oh, we could use like this. T, where T is I number T. No, T like this, and then we have it like this. Okay, that is fine. For all values is values to array. Also fine. I think we do array. We can do for int I is 1, len is all values that length, I smaller than length, and then plus plus I. Okay, like this. We can do yield return all values I minus all values I minus 1, like this. Okay, so this will give us the differences between all the values. So let's do that. For each var history in histories. Yes. For diffs is generate diffs history. And we could make this actually a extension function. Let's dump this into extensions like this, and this becomes public static. And now we can just do dot get diffs generate like this. Let's see. There's no implicit conversion from generic list long to system I number. Wait, what? Did I do something wrong? Let me see. No, this should be fine. What is it complaining about? To list, you can do that, but it should. Let's see, the type generic list long cannot be used as a parameter T in this generic parameter. Wait, what? No implicit reference conversion from collection list long to system. Okay, that's annoying. Did it work when I had it here locally? Let me just check. No, it cannot. That is weird. Because T is the value here, so it shouldn't care about this, should it? Would this work? Because now it's an IEnumerable. Oh, it's an IEnumerable. Never mind, I'm an idiot. I just passed in the wrong. I need to do history and not histories. Great. Okay. Sorry about that. So diffs. And we should probably keep a list of those because we need to diff this with the. While it's not 0, we need to diff it. So we have a, let's just set this explicitly because it's a list of long. And it will actually be like this, list of long, div, diffs, this new block. Actually, we can just omit the type for the second time and do it like this. And we can do if diffs.sum is 0, we are done. Actually, while we do, we don't check for 0 because it can be negative. It just needs to be not 0. So we don't check larger than 0, but it's not 0. Then we do diffs add diffs, and then we do diffs is diffs dot generate this to list like this. Okay, we'll do the right line, and we should probably make sure that we space this out properly. I wonder if it would be fun to print this out just like they did here. But yeah, that would be a bit of a pain to code. Let's do for int I is 0, I smaller than div this, like this. I just prefer mine to be here. We do console, that right line. First we write out the history, and now we do history. Actually, it's string.join. Let's do it as the input was history, like this, right? And then we do new string I plus 1 times 2, this. And then we do string.join. Let's also keep it with a space, and then diffs I, something like this. And then we do a console write line after, just an empty one. Let's run day 9 and see what this does so far. Okay, let's see. So yeah, we have it like this. So now we need to actually build that last value up, which should be fine. I cut off the 21 here, I think, for the second one, right? Yeah, I cut off 21 for that one, so let's just add that here, just for the next run. But basically it works the same, which is fine. And then so the last one, let's see, how do you do it? The third history, they have the 45, so then they do this plus this plus this becomes this, and then they diff it again, etc. So yeah, this is fine. So you just take the last values and you add them up, and then you should get your new one, right? 45 plus 15 is 60, plus 6 is 66 plus 2. Okay. So I think that should be the logic. So what we can do is int, no, let's do long next val is 0l. No, is actually history.last, right? And then we do here, before we do this, plus equals div stuff, plus equals, I said, div stuff last. Next value becomes this, right? So let's take our logic here. So we get 18, 28, 68. So yeah, that should be fine. And then we need to sum up all of those. So let's do long part 1 result is 0l. Okay. Yeah, we do a plus equals next val. Come on. Next val. Okay. And I'm wondering what the range will be for the full set, but we'll find out. Sum of new values. Part 1 results. This should be 114, right? Okay, that is correct. So now let's run it on the this one. And actually what I'm thinking is that you don't need to run the full set every time, but you just need to have like the last 2 or 3 values so that you can keep going down one. So you probably diff the last 3, then you get 2 values, and if they're not the same, you add 1. And I think that would be the optimization that you do here. But yeah, let's set test to false and try the histories. Boom, and it spams everything out, and now we get a big one here. Let's see if this is correct. Woohoo, gold star! Nice. But that wasn't that bad. So I fought my instincts to go against what they said to do, and yeah, it worked out, so okay. Part 2. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely zero. Then rather than adding a zero to the end and filling the next values of each previous sequence, you should instead add a zero from the beginning of your sequence of zeros and then fill in a new first value for each previous sequence. In particular, here is what the third example history looks like when extrapolating back in time. Let's see. Adding the new values on the right side of each sequence from the bottom to the top eventually reveals the new leftmost history value, which is 5. Yeah, you just minus all of them. Is it really that easy? It isn't, right? Okay, let's see. Part 2 is 0L. I'm scared already. Previous val is history 0. Boom, boom. Minus equals div stuff first. So this can just be 0. Part 2 result plus equals previous val. Previous val. Okay. So I can just call this part 1, part 2, part 2 results. That would be weird if this is it. Why do I do this? Let me just submit it, otherwise I'll have time to find it. That's not the right answer. Cool, okay. So yes. Let's switch back to the test. True. And let's run this and see what happens here. -3, -2, and 5. Okay. Let's see if we can agree on that. So that is 5, so that works. -3 for the first history and 0 for the second history. Wait. -3 for the first history, that is correct. And then we have -2 for the 0 for the second history, and all adding that together is 2. Okay, so that is wrong. Let's see, 5 -2 and 0. How come this becomes 0? So it's 1. So do I need to ignore, let's see. Let me see, you actually need to, oh, you can reconstruct it by just doing this. So you work your way backwards. So this 0 becomes 0, this 2 becomes 2, then you do this minus this, right? If it's 4, 2, you do 4, you do 2 minus 4 becomes -2 and you add that. Because you continue the series. And then you take, is that correct? Let me think. I'm just thinking, is there a way to because for me it was like I just remove these and then you get this one. Let's see, for the first example, -3. Where's the one with the 1? So we have 1. So if the forward case is so easy, why do I have issues with the backward case? Let me see. Because yeah, this one tells me what this one will be and how it should mutate, and this will be the difference. Okay, so let me see. So this one means that I can write a 3 here, and that will be the difference. Yeah, you need to work your way up. So once it's stable, you can repeat it, then you can use that to make the difference there. So in this case, we need to reverse this one. So previous value would be that. So let's see. So now we need to do for int I is diffs dot count -1, I larger than 0. No, yes, larger equal to 0. Decrement I. And we actually we do this -2. Let me see. So we do long previous diff is diffs dot last dot first. Right. This is a long value. This will be this value here is what we want to start with. Okay, and now we need to walk backwards and see what the difference is. So I think this one becomes diffs I dot first plus previous diff. No, minus previous diff actually. Minus previous diff. And this should walk us all the way up, and then we do in the end we do previous val minus equals previous diff. And I think this is the one that we want. So let me just step through this to make sure that it is correct. So this one, for the first one, will be 3. So now we have 0 and this becomes -3. This is fine. Previous is 1. Okay. Let's see. What's this? 2 minus 1, okay. So is 1 minus 1 becomes 0. I think we got it, boys. And this one becomes, right, 5. Yes, okay. Whew. That was a nice trick. So let's see. Part 2 will be 2. Let's see. Yes, okay, so let's run it on the real input. Okay, that took me a bit longer than needed to figure out, but I think it's fine. And then we still print out all this stupid stuff, and the answer is 990. Woo! Second gold star in the bag. Ah, that was a fun one. I learned something from this one, which is always nice when you learn something. Yeah, I think this is really cool because this actually teaches you how to work out series patterns. So that's actually pretty cool. I wonder if it works for, because there's also ones with like multiplication and stuff, but for this with like simple increasing ranges, I think this is pretty cool. And I can't wait to actually try this on some some challenges to see if this works. Yeah, this was a really fun one. It's not too hard. If you look at the data, you can figure it out. It doesn't need any domain-specific knowledge. Learn something new. I really like it. Yes, I like it. I'm a bit sad that the stream is already over again. But yeah, such is life. Maybe tomorrow is a longer one. So yeah, thank you everybody for watching. I hope you liked the stream. If you have any feedback, there is a Discord link in the description. There is a Telegram link in the description, plus my Twitter. So if you want to reach out, feel free to reach out. If you liked the video, please drop a like, subscribe if you haven't subscribed. I'm trying to get to 1,000 subs and 3,000 hours of watch time, but that's a whole different story. But yeah, thanks for watching and hope to see you again tomorrow. Bye bye.